but I will try to give you some overview about the different catalogs and standards that already exist. What is happening in the community to integrate all these catalogs in the Arctic domain and also in the other domains. And then we will focus a little bit about the observation facility catalog, how it works, how we can search the data and information inside. And at the end, you will have some short exercise, so you will be able to upload your own facility to the catalog. We know that information related to research site is essential when describing the context of observation, and it's a key element of site-based research infrastructures and their catalog. So it is one of the reasons why we are trying to collect all these informations. One of the best standards that is developed is VIGOS. I mentioned about it also because a light version of VIGOS is implemented in the observation facility catalog. So the World Meteorological Organization Integrated Global Observing System, it's a framework for all WM observing systems and for WMO contributors to co-sponsor observing system in support of WM programs and activities. An important aspect of the VIGOS implementation is ensuring the usefulness in relation to VIGOS observations. The complementary type of metadata are therefore required, namely discovered metadata and interpretation, description, or observation metadata. And all that information can be found and structured in the VIGOS metadata standards published in 2019. All the data sets collected directly through the WMO and VIGOS are available in the OSCAR Observing System Capacity Analysis and Review tool. So you can find standardized information about the infrastructures and facilities in this system. So this is one of the biggest database, the biggest catalog about the infrastructures and facilities that already exist. But how the structure of the metadata used by VIGOS looks like. The VIGOS metadata standard consists of multiple components. The 10 of them are basic, and then they are divided into sub-levels with precise description. For us, we can look on the main structure. So as I said, VIGOS metadata standard consists of multiple components. So we have observed variables, purpose of the observation, station platform, which we'll back to, environment, instruments and methods of observations, sampling, data processing and reporting, data quality, ownership of data policy, also licenses, and contact. And none of them are mandatory, and in observation facility, we have a light version of that. As we see, one of the category is the site. Here it's called the site platform in VIGOS. It's defined as the observing facility and includes fixed station, moving equipment, or a remote sensing platform at which an observation is made. Next, very important, relevant subset of the VIGOS metadata standards is the description of the observed variable. And this variable specifies the basic characteristic of the observation and resulting data sets. And it's connected to the GCMD keywords, which was mentioned before in a few trainings, and we'll come back also to this today. The VIGOS metadata standard also provides a set of code lists to be used for some of the feeds, especially for the site platform, for sites, like for the site operation status, station type. But yeah, let's go to the next slide. Yeah, so going into the details for the station and platforms, we need to, we can see the categories for the metadata, like region of origin of data, territory, station and platform name, type, and for example, for type, we have drop-down list that we can choose what type of the platform we are working with. Identifier, which could be from delivered by the VIGOS, but there are also some new work in this direction, which I will show you in next slides. Geospatial location, data communication method, station operating status, and station cluster. That are the last four categories which are important for the platform description. But as I mentioned about the identifier, there is a ongoing discussion about the persistent identifiers for the instruments, as the instruments play an essential role in creating research data. Given the importance of instrument and associated metadata to the assessment of data quality and data reuse, global, unique, persistent, and resolvable identification of instruments is really crucial. The Research Data Alliance Working Group, Persistent Identification of Instruments, PID-INST, develop community-driven solution for persistent identification of the instruments, which is present in this paper by Markus Stocker and all, that you can find reference at the bottom of the slide. Based on the analysis of 10 use cases, PID next developed a metadata schema and prototype schema implementation with data side and representative persistent identifiers infrastructures and institutional instruments providers. This implementation demonstrates the viability of the proposed solution in the practice. So this is something that will be happening in the future. Of course, you can have a persistent identifiers for the one instrument or for the set of instruments, like for the automatic weather station. And it will include also the history of changing the, for example, components in this, for example, automatic weather station. So in the paper, there was proposed a schema for the metadata information that it's required for the instruments, if you would like to have persistent identification for that. Of course, it's not a standard now, and if you will go into different catalogs, they are not using the unique identifier, or they use their own. But it's like with the DOI. If you go back for the several years, there were different standards, and now DOI for the papers are more or less standardized. So the work for the persistent identifiers for the instruments is going more or less in the same direction. But as I saw, there is a different solution in different databases. And if we look into the details, there is several catalogs that are collecting the information about the facilities and areas in the Arctic, in the polar areas. Here we have example, for example, from the Svalbardkartan, where you can have an overview of the facilities in the Nalesund area. It's also worth mentioning that it's all the same information you can find in the SIOS observation facility catalog. We are now implementing all that data sets to our catalog, so it will be both side communication. You have also different catalogs, like from Interact, from Interos, or from the European Polar Board. But if you go and look for the details, if you go to the European catalog, you can find like 10 or 11 facilities that are at Svalbard. So we know that it's not what we are like to find there. And of course, it's similar to the databases and repositories. The problem is about the interoperability, because at this moment, catalogs are not interoperable. So there are some movement about making these catalogs interoperable. So of course, it will be connected with the persistent identifiers, proper metadata standards, etc. But here we have an example of a really interesting paper that focus on the few catalogs. Also, we include the Interos, SIOS, ICOS catalog. So they make an overview and analysis of the catalogs and give some recommendation about the harmonization. So the main recommendation for harmonization of data access was that site information should always be exposed in both a human readable and a machine readable format, and identified using a persistent identifier. This especially applies to the proposed set of minimum information, for example, for the core fields. The investigated catalog feature a wide variety on different formats. Nevertheless, it's recommended to support common data formats for site record information that can easily represent multidimensional data such as JSON or XML. Ultimately, a catalog should have the liberty to decide their preferred data formats and also have to serve that information while also supporting common formats. In the case of sample structured information that does not feature any multi-value fields, CSV would be sufficient for that. It's also important to have a proper recommendation and to have a proper data license for sharing information in the catalog. So while we need to apply the license if you would like to harvest the information from the catalog, it will be possible. The data license should permit the usage, the free usage and attribution. And of course, an example of such a license is the Creative Commons license, as it allows user to copy and redistribute the material in any medium or format and to remix, transfer, and build upon the material as long as appropriate credits is given. So this is something that we need to remember if you would like to create the interoperability system of the catalogs. Similar work is done through the Event Refer project when SIOS is a partner. So one of our tasks, which will end in the next year, is just to create a common hub to connect few catalogs that are in the different standards. So we have our Elder catalog in the standard ISO 19115-139. We have ANAE catalog in the same standard in the GeoNetwork repository. We have ICO's Carbon portal, and we have a Live GeoNetwork, and also SIOS Observation Facility catalog. So the idea is just to create the common hub that all the information will be collected. And it looks like that now we agree that data cut as a metadata schema will be used. So some of the data of the catalogs will just implement this schema, or it will be done mapping between existing standards, because it's quite easy. And for some of the catalogs, it's also very easy just to export the data to CSV and then convert to the DCAT standard. So as I said, this is ongoing work, and the solution will be sell to the whole and refer community, and then hopefully implemented to the EOSC, European Open Science Cloud. So let's see how it works in the next years. Yeah, this is just the summary of the standards in databases that are analyzed in this process. And the crucial part, the core part of the connecting these catalogs is to define the core fields. And for this process, it has been mapped that the site name, site ID, location, description, and observed properties are the crucial one, which should follow the same standard. Yeah, but let's go step forward and look on the observation facility, SIOS observation facility. As you know, we are dealing with different types of data sets. Some of them are historical, some are present, some are from some projects. So it's crucial just to map where this observation has been done. As our partners from which repositories we are harvesting the information, they are using the different standards. Not often the information about the facilities are provided. So we developed the observation facility catalog, which provides an overview of the observation facilities which collect SIOS data. An observation facility can be one instrument or a collection of the instruments. As it's defined in the WMO, facility is a place where observations are made, and it's referred to all type of observation platforms, whether surface-based, space-based, land, sea, lake, or river, fixed or mobile. The annotation that we are using in the observation catalog is standardized following, as I say, WMO standards as far as possible in order to make entries unambiguous and interoperable internationally. The purpose of the catalog is to make better use of the existing research infrastructure by facilitating the search for given parameters and their location. In this way, duplication can be avoided and new measurements can be collocated with existing ones. The catalog may also be used to gain a simple overview of the collected parameters and how to access to the data. The search interface allows users to search to the GCMD keywords, status, or type of the observatory, but we will be able to see this later. And the catalog was mostly developed by the Norwegian Meteorological Institute with input from the task force from Norwegian Polar Institute and Agner Wegener Institute. But what you can find in the catalog, information collected through the OFSTER are used when entering SIOS metadata and data into the SIOS data access point. This allows also to build a joint system of operation between the database and the research infrastructure. So in the perfect, when the system will be perfect, you will be able to connect the data access portal with the observation catalog and just move between the data sets and the facility. But how to search? So you can find our catalog on the right side, observation facility catalog. Yeah. So what you can find here, you can find the map. We can use scroll down and up to find the proper facility. At this moment, there is around 200 facilities, and we are still adding the new one to the system. If you will choose the proper facility, you will go to card of this facility. So you can find the location of this instruments, basic contact information, email, institution, then the information about the type and status of this instrument. If it's core data or if it's related to any SIOS project, it will be mentioned here. You can also have our WIS ID. It's not mandatory, but if it's possible to add this to each facility, and then you can find in the WIS database more information about the project. As the Svalbard Science Foundation now working on the new WIS database, we are making efforts to make catalog connected directly to the WIS database, so you will be easily moved between these two databases. But I think it will take some time, but this is the plan to how it should work. Of course, the information about the spatial location, description of the environment, and one of the probably most crucial part is the observed variables that are measured at this station. So you have the GCMD keywords, information about the start date of the measurements, and then some additional information about the parameters. All of them are not mandatory, but so it depends only on the scientists what we can find here. Of course, you can also add the photo to your facility description. If you scroll down, you will find the full list of all the instruments and sites that are uploaded to the catalog. So you can go just search one by one to see what is inside. Let's go to the searching interface. You can search by the free text in the observation facility. So, for example, if I will be interesting something that have world weather inside, I will have a list of all instruments that have a name weather inside the name. So I can choose the automatic weather station in Kongsbergen, apply, and then I will directly go to this place and see. Here I have a short description, name, variables, contact person, and additional information. If I would like to go into details, I will need to click on the name on the map or here on the left side. So if there will be a photo, it will be visible here, or also additional description can be found. Let's back to the array catalog. And of course, if you know the RIS ID, we can search through the RIS ID. We can search through the institution, for example, IT. Let's delete this one. Apply. And then we see that we have like list of several instruments that are assigned to UIT. For some of them, you can also find the landing pages for the data sets. So it's also depend of the how people what to deliver to the description. So just reset this one. Yeah. And for the observed variables, it works similar in the data access portal. For example, if I would like to search for the glacier mass balance. Yeah, let's say cryosphere ice sheet glacier mass balance, apply. There is some information because we are changing in Drupal, but the system is working. Yeah, so we can easily see all the information about the about the mass balance networks in this area. For example, system Hansbrand, Werenschelbrand, with all the information about the information place, sampling procedures, and etc. And it's important to know that not the whole list of the observed variables from the GC keywords are applied to the observation facility catalog, but only this one that are in the system. So if you are looking for specific GCMB keyword and you cannot find it, that means that nobody upload the information like that to the observation facility catalog. You can search through the status of the infrastructure. So for example, we can, let's see, what closed facilities we have in the system. Yeah, you can see that there is several of them. In the area of the Isfjord, and there are mostly the old permafrost boreholes. For SIOS project, at this moment, there is only SIOS Infranor project implemented in the catalog. And I think that's around 70 to 80% of the infrastructures that have been developed to this project are available in the OFC. So you can also search directly to these instruments. You can also search through the observatory. So if you are, for example, interested what instrument or facilities are allocated at Sverdrup station, you can do it. Probably there is not so much as we are applying now we are adding now the information from the Nalesund area to the system, but you can see that 2 of the instruments are assigned to the Sverdrup station, but it's also up to the people who are uploading all the information to the system. It's just depends on them. Yeah, and the last type of searching, let's reset this one. Yeah, and last type of searching is the type 1. It's according to the list from the Vigos that you are marking where you're uploading the information. So you can easily go, for example, if you are interested in the mobile C platform. Let's see what we will find. Yeah, at this moment there is only one ferry box in the Nalesund area. If you look at, for example, fixed land platform, yeah, you can see that it's much more of them. So those are the most. This is how you can search in the observation facility catalog. As we are moving now to Drupal 8, I think that the interface will change a little bit, will be more user-friendly, but all the types of searching will stay here. Before we go to the next step, so do you have any question about the facility catalog and how to search here?